Hello everyone. So as you may know, we have a guest speaker. Let me introduce our guest speaker. So our guest speaker, Jeff Chin, is a Purdue University graduate and is Vice President of the Engineering and Business Services for Gaylor Electric. Jeff is also responsible for the leadership of their Virtual Design Center, pre-construction services, fabrication, and all around the project delivery. His nearly 30 years of large project experience has equipped him with a thorough understanding of project delivery and performance. And also, he is able to provide a unique insight and value-driven approach for Gaylor Electric project. As a Gaylor Electric leader, Jeff is recognized for his team-oriented quality of integrity, spirit of work, and history of cultivating excellent client relationship. Please welcome Jeff with a big applause.
Thank you, I appreciate it. This is pretty exciting for me today, so I hope this is good for you as it is for me. Is that okay? So to do that, could I ask for one thing? Could we have a discussion with each other instead of a presentation? You know what I mean by that? Isn't it better to have like some give and take, and I'll say something and I'll guarantee you today I'll be a little confusing on something. Because I'll think I know what I'm talking about, but you might have a question. You might say, hey Jeff, can we talk about that a little bit? Is that cool? John, did you have something to go over first?
No, that's
No.
not a good class.
Okay, good. Okay, well, it's a pretty good weekend for me this weekend. So let's go backwards, okay? Packers won. That's pretty cool, isn't it? Okay, now come on. No? You can't believe it. You're a Bears fan, aren't you?
No, I'm a Falcons fan.
Okay, well that was not too bad either. So I'm only 184,000 out on my season tickets at Lambeau Field, so I'm right around the corner, right? In 25 years, I've gone from 102 to 84,000. So I don't know whether I'm happy with them winning, because people keep buying, or I would rather them lose, and I get some spaces up in line, right? So then we go back. Colts won, amazingly, right? Who else is a Colts fan? That many. Wow. It's going to be a rough crowd. And we played a pretty good half of football here, too, didn't we? So that's pretty cool. Stadium fun. Okay, well, today, as we said, let's do a little bit of a discussion, guys. I thought this would be kind of a good agenda for us. It's structured, but we can bounce back and forth as we need to, if that's okay. So one of my personal commitments to life is that when I start a meeting, we do a safety moment. So we're going to do a little safety moment. We'll try to make some fun out of that, okay? How many of you guys have been around a safety moment before at a job site? Cool. Okay. A little bit of background about me, but it's not really so important about me. What I'd love to do is we talk about opportunities I've been able to experience because you guys are on the threshold of those same opportunities and experiences, okay? So we'll kind of talk about my career a little bit, but it's really about how we can help you all, okay? Your opportunity course. I thought we might do a case study today. You know, electrical stuff's kind of hard to drag in here and have a big dog and pony show without somebody dying along the way, right? Okay, so we'll do a little case study. It's not the most complex job in the world. It's a little job down in Westfield called Grand Park, but it's something we can all picture in our mind, okay? And then we can talk through it. And that'll be kind of from a subcontractor's point of view. But we can talk about how we engineered the job, why we satisfied the customer's needs, and we've got a copy of the estimate too as well that we can look at and see how we came up with our price. So again, not a very big job, but something there. And then I just thought we should leave some time for open discussion. Is that cool? Okay, so you're going to get a mix of Texas and Louisiana talk here today. Okay, there's going to be some bad grammar. Laugh, okay? Okay, thanks. Okay, so one of my favorite safety topics is hierarchy of controls. What a name. Who in the world came up with the name? Hierarchy of controls. I don't know. This comes out of a group called the Construction Institute Construction Industry Institute, CII, out of Austin, Texas. And they are a group of major scale owners that study the best projects that have ever been executed in the world, okay? And here's what their study said. If you, one of many. If you want to make sure that people on a job site go home healthy every day, we need to quit focusing on PPE, hard hats, safety glasses, hearing protection, steel-toe shoes, that kind of stuff, right? We need to raise our expectations. We need to raise them all the way to the top bar on there, which says what? Blue. Thank you. So, if we can figure out how to eliminate hazards well before they happen, that is the best way to send people home. Have you all ever been on a job with fatality? You have? Oh my goodness, you and I. Anybody else? You? 3 of us. I hope the time we're done, that when you teach this class, you answer that nobody's nervous is no, right? Did it make you sick? It was awful, wasn't it? And we weren't even the family. Was it your family member? No. Can you imagine what it's like for that person's family? It just can't, it's just not acceptable anymore, right? So accidents aren't acceptable. So what I would say is that as engineers, we have a unique place in life. We can start at the beginning and figure out how to not have a hazard happen, right? So now let's see if my little stab at trying to go online and find us something that will demonstrate this. Eaton, before we hit start, we buy a lot of power distribution gear, motor control centers, switch gears. These are basically the control panels and circuit breaker units, we'll talk about them later on a little bit, that control the flow of electrical current on our job site, right? They are, most times, very safe and reliable. There is one thing that happens though, called arc flash. There's a small fault inside the gear, and it explodes. What if we could use our hierarchy of controls to eliminate, why is that up here? To eliminate that problem. Is it dragging up there? Okay, good. So 2 weeks ago, I had the opportunity to meet the team that's conquering that. Uh-oh. We're going to figure out how you can hear this.
Risk, but even those solutions leave
Are we gonna start over?
equipment in harm's way, never satisfied with the status quo. A
Help
team
me out, folks.
has been working on innovative ways to improve the safety of operators and protect the equipment they work on. That's Adams Baker, Team What's Way, never satisfied with the status quo. A team
This
has
is
been
okay.
working on innovative ways to improve the safety of operators and protect the equipment they work on. That's Adams Baker. He works with a low voltage switchgear team at Eaton.
This became our driving force and challenge. Reduce the incident energy from an arc flash event to a level rarely seen in our industry. In other words, someone needs to be able to stand next to our switchgear and in the event of an arc flash, not just survive, but walk away unharmed. And we wanted a solution that protects the equipment too.
This, you may know, is a significant task. Add it up. Even with the existing systems on the market today that reduce the risk of arc flash, there are nearly 30,000 arc flash incidents every year. The explosive force and intense heat produced by arc flash events injures thousands of people and kills hundreds. And arc flash events often destroy switchgear, leading to costly downtime while critical parts are repaired or replaced. A catastrophic arc flash event in low voltage switchgear can release 15 million joules or more of energy. That's like detonating nearly 2 pounds of TNT inside your equipment. Reducing or capturing that energy is the key to protecting personnel and equipment. 3 or a 30-cycle arcing fault with no energy reduction or containment methods. The
Can I
result
just stand in front of that?
The explosive force decimates equipment and threatens the safety
don't do
of
that.
operators and maintenance personnel.
Most methods for reducing arc energy rely on tripping the main circuit breaker to clear the fault. Unfortunately, low voltage power circuit breakers can take up to 4 cycles or 67 milliseconds to open. This is simply not fast enough. The ideal solution is a system that operates faster than the circuit breaker to reduce the incident energy even further. In fact, our team set out to develop a solution that reacts so quickly that the damage from an arc flash event is dramatically reduced or completely eliminated, not to mention what that would do for personnel safety.
There are 2 modes of equipment damage and personnel injury that result from an arc flash event.
The most obvious is the extreme heat, molten copper, and flames that are discharged during an arc flash. But before that happens, an equally dangerous pressure wave ruptures the enclosure and ejects shrapnel at high velocity. According to testing performed by Eaton, this pressure wave peaks at 7 milliseconds from the onset of the arc flash, or less than 1/2 of a cycle. So the system must operate at least that fast to provide maximum protection.
Eaton's arc quenching switchgear was developed with that goal in mind. The technology is designed to detect and quench an arc flash event in less than 4 milliseconds. That's less than 1/4 of a cycle, well before the pressure wave reaches peak destruction. The team performed a 30-cycle arcing fault test at 635 volts and 85,000 amps of available fault current. And
3, 2, 1.
the arc quenching switchgear survived undamaged and had a person standing in front of the gear, they would not have sustained burns or been injured by flying debris.
After an arc flash event, the Eaton arc flash relay indicates the location of the fault inside the switchgear. All you need to do is evaluate the equipment, remove the cause of the fault, and return it to normal operating condition. The time required to return the switchgear to service is reduced to a matter of hours instead of waiting weeks or months for repairs to be made. After the arc quenching device is triggered, it must be replaced. If you don't have a spare available, you can still re-energize your switchgear, but your protection will revert to the clearing time provided by the arc detection relay and the main breaker.
The result is dramatically reduced incident energy levels, which minimize or completely eliminate damage to the switchgear and yield superior personnel protection. Protection that meets or exceeds the IEEE C37.20.7 guide for testing metal enclosed switchgear for internal arcing faults. Arc quenching switchgear provides arc resistance without the need for ducts, plennets, special construction, or venting inside the room. And it maintains its arc-resistant weighting even with breaker doors open and breakers removed. The system is always active when power is applied. It does not require any operator intervention when properly maintained. And it contains technology to prevent nuisance activations from the light emitted when an air circuit breaker interrupts a downstream fault outside the switchgear.
Here at Eaton, we're very excited to provide a best-in-class arc flash safety solution that provides superior personnel protection, advanced equipment protection, and dramatically reduced downtime in the event of an arc flash. With arc quenching switchgear, the future of arc flash safety has arrived.
Pretty cool, huh? So I flew down a couple weeks ago to Eaton's design centers in Chicago, or in the Carolinas. 4 up in 2 days. It was a hell of a trip. Met Adams, and he shows us this video, and I said, "That's revolutionary. Now that's pretty cool stuff. Have you ever heard of hierarchy controls?" And I thought his plant manager was going to jump out of his seat. He's like, "Adams, all he talks about is hierarchy controls. Hierarchy controls. How can Eaton eliminate hazards?" That's, in my mind, the top. Does that feel right? That's what we do. So if I could just leave, if there's one thing today, just remember that if you can see these hazards and eliminate them, you probably save somebody's life. Fair enough? Good enough safety moment? Okay. Okay, so a little bit about my career, and again, use this to springboard yourself. Okay, so way back in 1989, I had the opportunity to go here to attend Purdue in BCM. Okay, it's called BCT back then. I don't know why we changed it. Was joking around about my college career search with John, and it was 15 minutes. I walked in, decided that's what I needed, and left. Didn't understand the power of going through engineering school. Congratulations, guys. You got a bright future. Okay. So my first job out of college, moved to Wisconsin. Because why do you move to Wisconsin? It's beautiful, right? Lots of snow, great skies. Okay, it's okay. Green Bay Packers are there. And worked for a mechanical contractor called J.F. Ahern Company for 10 years. And J.F. Ahern really did process mechanical. And if there was one thing I learned there outstanding was understand how the job works. Understand how the job works. If you're gonna, it's one thing to know how to put a piece of pipe in the air, hook up a pump, or set up a piece of concrete formwork, but it's all the other thing to understand why you're doing it and sequence the job correctly, help the craftsman understand it, because the client picks up on that big time. Fair enough? So anybody done a process mechanical internship here? Any place? What kind of, tell me about your background a little bit, somebody. What kind of internships have you done?
Worked with the MWC, mechanical contractor, in
Bingo.
a lot of Boilermaker type of work. I think that might fall under process mechanical.
But it's the same. Good friends with BM. You know Matt Clark there by any chance? Yep. Okay. That's exactly it. Process, high steam, high energy stuff, boiler piping, boiler stuff. So same kind of, exactly the same contractor, different place. Where else? Done an internship yet?
Yeah, Wolves Construction in Chicago doing high rises.
Bingo. Yeah. So a little different. You're vertical, but you can understand certainly the need for chilled water pipe, hot water pipe, heat and cool your buildings, and go from there. Okay. Who's yours? You did an intern? Yeah.
Oh yeah, I was working out in California for a while ago.
Okay.
Like water treatment plants, water treatment.
We're in. So a lot of my work, you'll see the next slide, you'll really like, this has clarifiers on it. You'll get excited for a second. Okay. My wife decided that she wanted to live in Indiana, and having a happy life at home is pretty important to me. So we investigated where to come to, and I had the opportunity to work for Bowen Engineering. How many folks have been in a class with Dr. Bowen? Or folks, great company, fantastic company. I mean, you pick up on that from Mr. Bowen? Cool guy, huh? Yep. At Bowen, I started as a project manager and worked my way up to our senior vice president, and pretty much did everything in the company outside of corporate duties there. So operations groups, estimating, pre-con, traveled all over the country, had an opportunity to run an operation in Texas. That was pretty hard, and got there. So guess what happened again? Not learning from my first experience, my wife said, come on, you can get it. I want to live in Indiana again. Right? So again, happy home life makes great strategy in your business. It's absolutely true. So I was able to join Gaylor. Had a great friendship with President Gaylor, Chuck Goodrich, through Purdue and stuff, and got to go there. So how's that feel? What are your thoughts about that? It's kind of interesting path. Yes, sir.
Just interesting that you were able to, I mean, how does that conversation start where you move from one company to another?
Well, it was interesting. So Doug Bowen called me one day down in Texas. And he says, Jeff, you're not happy. What's going on? And I said, well, he obviously worked there a long time. Wives all know each other. We all know each other's family. And Debbie's just really not happy. She says, well, you're welcome back here anytime you want. I mean, it's just the same company. Just come on back, right? And I said, well, I kind of feel like when you go somewhere, you need to honor your commitment. You need to make that thing work, or you need to be accountable for that, right? And I thought that would be really not a very good deal. And I probably said something else right in there. It'd be a really bad deal if I said, I'm going to accept a failure here and then just step back into my old role here. I don't think that would be fair to the other people. Doug says, that's an interesting perspective, but you're still welcome here. Anything you want to do. So A couple weeks went by and I thought, you know what, I'm gonna reach out to some of my trusted friends in the world, people that know me and know what's going on in the industry. And one of those was Chuck Goodrich, the president of Gaylord. And he says, well, why don't you come here? We need some people with larger scale project experience. Maybe somebody who can help us increase some of our engineering and fabrication, which are tenets that are really strong in the mechanical world, that are just emerging in the electrical world. You know what? That's kind of interesting. So I gave my boss, Doug Bowen, a call. Has Doug been in any of your classes at all? Bob Bowen's son? He is an ace. The guy understands the world and people as good as anybody will be around. And he says, you know what, Jeff? I think that's a good opportunity for you. But you're still welcome at Bowen. You make your decision. So we went home. Debbie and I took a couple weeks, and we decided to make a move. And that's how it was. So is that fair, honest? You know, it's kind of funny. Out of your struggles come some victories. You got to embrace that hard day. Fair enough? Okay? Okay. So through that, I thought we could give you a big dossier on pictures, but on jobs, but pictures are more fun, right? Okay, so at Ahern, I was in our water and wastewater group, built water and wastewater projects really all across the middle part of the U.S. Some large, some small, conquered some neat stuff. One of the first ozone disinfection systems in Milwaukee in the country. It's kind of neat. Which then allowed me to springboard into industrial water treatment. So if public works, like over here, the city of West Lafayette, drinking water or sewage work is kind of like the minor leagues, industrial work is the major leagues. Okay? The pitches move faster, everybody runs harder, you got to hit the slider all of a sudden. Okay? Really cool stuff. This happens to be a reverse osmosis water treatment plant skid. I didn't have a great, I like that one. Okay. This is a mine water reclamation plant in Grundy, Virginia. Does anyone know where Grundy, Virginia is at? I wouldn't if I didn't ever know there. You heard of Hatfield and McCoy, the feud, remember? Like once in Kentucky, there's this little piece of Virginia that connects to Kentucky, and it's on the other side of it. This is glamour. I mean, if you want to impress somebody, tell them you've worked on a job in Grundy, Virginia. Fair enough? Come on. Okay. So this facility, which is one of mine I would have to be responsible for, has every single major emerging technology in the country. It takes 2,000 gallons a minute of pure brine, fully concentrated brine water with 6 other trace minerals in it, and it that was previously being discharged into a river, killing everything in the river. And our team was able to convert that into pure water, which the coal mine could use to process coal. So their P&L went up because they could process more coal. And it made a pile of rock salt, which we could give away to the county. And in this county, in Virginia, was so impoverished, they had never once been able to buy road salt. So people would slide off the road and die. Never once in their history had they ever had rock salt. Avoiding those two things increased the P&L and avoided a hazardous problem in the environment. Pretty cool, huh? Okay. It was a partnership between our company, General Electric, and an engineering firm called HDR Engineers. HDR. You guys, does HDR come and recruit here at all? If you ever get a chance, you should see them. So it's kind of cool, huh? It's got a thermal evaporator. It's the same technology you make instant coffee with. They actually brew coffee and then run it through this crystallizer evaporator, and that's the technology we use to separate the final salt out. Had a nice opportunity to work at powerhouses. Has anybody ever gotten to work or visit a coal-fired powerhouse? BMWC guy, again. So you were like, I got that, built a place boiler, right? What did you do there at BMWC? What kind of projects you work on?
It was a dust collector project around the transfer area for the coal coming in. Basically just replacing the old system because he basically didn't do anything, and it needed to meet EPA standards. And basically what we did is took out, moved the old system and installed a new one. Pretty long project though, probably a year long, considering not very many projects go that long industrial.
Okay, so is it playing Schaefer or something?
Yeah, Schaefer.
Yeah, Schaefer Station, okay.
Yeah.
Well, the only good thing about this site is that within 20 minutes, you can go get crawfish from here. That is literally called Big Cajun Powerhouse. And you drive up, it's too bad I didn't have a picture of it. On the other side, you drive up and there's a huge crawfish painted on the site. Like, I don't even know, where you get a guy that'll paint a crawfish, right? It's okay. So this project was also an environmental compliance project. The challenge here that the client came to us with was there's a certain amount of stuff going up those smokestacks that if we don't get under control, they're going to shut us down. They meaning the EPA. And it was for good reason, right? Do you want to live in a polluted world? I don't. Okay, so it's fair. But if the plant, this was in October, if the plant wasn't corrected, if the problem wasn't corrected April 1st, they would lose their entire operating license forever, and it's almost impossible to relicense an operating coal-fired powerhouse. That facility right there is 2,000 megawatts. That's about 4 million people. Okay, reasonable problem? So in 12 weeks, we were able to install $43 million worth of work there that included a new industrial water treatment system, a new SCR catalytic reduction unit, ammonia feed system. We worked 24 hours a day, 7 days a week, with 1,500 guys, including the design crew. Kind of cool. One night, I got a call, my wife. She says, hey, and a job of that scale gets a vice president once in a while. Okay, on it. And she says, hey, you didn't call your daughter last night. And I'm like, why? Well, should I? She says, well, it's her birthday. And I said, hell, I can't remember what day of the week it is, let alone what day of the month it is. It's cool. You guys have that opportunity too. Does that sound fun? Can you tell I'm pretty proud of it though? It's the best part of our world, right? You can be proud of what you do. Okay. Because Big Cajun wasn't exciting enough in 14 weeks, I decided that we should go work in the refinery world. Outside of BMWC, did you ever meet John Davis? By any chance that sound familiar?
No.
Okay. So who has had a chance to work in the refinery world? Anyone? Okay, where at?
Down Baton Rouge.
Baton Rouge?
Yeah.
Okay, Big Cajun is just out north of Baton Rouge, so we can probably talk fast and blurred right now. No hear each other. Where at? What facility?
Shell
Shell North. Okay, what kind of unit were you on?
Anything in particular? I work with the general contractor, mostly just did foundation work, so I never really worked.
Which general contractor? Cajun contractor. Yeah, fantastic. Tough group, right? I mean, they knew how to get stuff done. Still do, right?
Yeah.
Did you get to read the book the guy wrote, the Cajun founder, on labor sourcing? And
No.
it's a cool book. He's a really smart guy. Okay. So our team was able to springboard what we knew about water and environmental compliance into a very niche market in refinery work. Okay? So pretty cool stuff. Refineries use a ton of water. Obviously, they have to cool stuff and heat stuff up and make steam and cool it down again with quenches. And there was no one in the world who could go there and see it and handle that. So our team was able to do that. Pretty fun. Again, what was the one thing I learned at Ahern? Does anybody remember? At the mechanical contractor, I learned one thing. Know how the project works, right? Because once you know how the project works, then you're able to understand how you can fit into it and make a business out of that. Fair enough?